All right, so John is asking, how do you change the default time frame when BloodHound starts? So actually, John, you can't change the default time frame. So let me explain what that is here. So let me pull up a chart. Not that one. Okay, nope. Actually, I did have the right one. Yeah, let's pull up this one. Okay, just a moment here. I'm going to load up a new chart template here. Okay. All right, so what John is talking about is, you guys have all seen this default time frame in BloodHound, right? And so typically you'll just take a solver and you add your solvers right underneath the default time frame. And then if your strategy is using multiple time frames, in particular, you guys should always be using higher time frames. So that's discussed in previous workshops. But so let me just add how about a 5-minute time frame here, right? And then I'll go in and just add say a 10-minute time frame. All right, so I've got multiple time frames on here, multiple charts. So the default time frame, you can never change it. All right, as you can see, the window's blank, but the time frames that you add, you can go and change. So what the default time frame is the chart that BloodHound's running on. So let me refresh this here, and I'll just cancel that for now. I'll name my BloodHound file here in just a moment. So whatever chart that BloodHound is running on, that is the default time frame, right? So as an example, right, all these indicators here, like these moving averages, right, the stochastics, the MACD, all four of these indicators, right, their default time frame is whatever the chart is, right, because these indicators are put on this chart, so that is what their time frame is. So in this case, this is a 5-range chart. So the time frame, the default time frame for all of these indicators is a 5-range. So the same thing applies to BloodHound, right? BloodHound is just an indicator, right? It may be a fancy looking indicator, but in the end, BloodHound is an indicator, and it's constrained to the rules of that all indicators have to follow when running on a chart. So the default time frame is always locked to whatever the chart is, right? So what that means is that the default time frame is a 5-range chart, since that's what the chart is set to, and so these two solvers here, the bar direction and the indicator slope, both of these solvers are going to be running on the 5-range chart. So that's what that is. So if you want to change the default time frame, you have to go here, right, and change the time frame of your chart. So now the default time frame now is a 3-minute chart there. So there you go. So if you don't want any of your solvers to run on the default time frame, so let's just say, so we have here, let's do something practical. So let's just make this a 1-minute chart, and let's say you want all your solvers to run on a 5-minute chart on a higher time frame. Then all you need to do is just take your solvers and move them down, right? And so now all of the solvers are going to be running on a higher time frame on the 5-minute chart there. So that way, basically, I would have all my logic running on a 5-minute chart, and there's nothing running on the 1-minute chart. So let's delete that 10-minute there. Yeah. So if I just built a real simple, crazy system, right? So you can see these solvers have a little 5-minute title on the top of them, right? So we know that these solvers here, these nodes, are running on a 5-minute chart. And I could just, build some logic, and there we go. And since I deleted, whenever you add a chart, or whenever you add a chart or delete a chart, basically add or remove a time frame, you have to refresh the chart so that NinjaTrader acknowledges what you've done. So you can't add and remove time frames or chart data on the fly with NinjaTrader. That's one thing that we couldn't get Ninja to do. So we do have to refresh the chart whenever you manipulate the time frame or the chart data. So basically what I built is, I built a little mini system that's running on the 5-minute chart, but we're seeing it on the 1-minute chart there. So there you go. I hope that helps you understand what's going on there. Okay, good. Yep. All right, so Thomas wants to split the trading day into 2 sessions. Okay. Yeah, Thomas says it should be fairly simple. All right, so let me just kind of paraphrase what Thomas is wanting to do. So Thomas has 2 trading sessions during the day, right? So he has a 6 p.m. to 3 a.m., right? So an overnight session, and then the other session is from 3 a.m. To 5 p.m. Let's see. Oh, okay. So there's, well, Thomas, it's going to be a little tricky. So there's no gap between your 2 different sessions. All right. So one session ends at 3 a.m. and another session starts at 3 a.m. So, all right. And so, sorry guys, let me finish paraphrasing the question here, repeating the question so you guys understand what's going on. All right, so once again, Thomas is trading with 2 different trading sessions, right? An overnight and then from 3 a.m. to 5 p.m. So Thomas wants to know how to close any trade that was open during session 1, and he wants to close it when session 2 starts. And I guess the same would be if a trade is open during session 2, he wants to close that trade out before session 1 starts again. Okay, so let's see. Okay, so we have session 1 is from 6 p.m. So this will help you guys understand or visualize Thomas's question here. So that's session 1. Then we have session 2. It's going from 3 a.m. to 5 p.m. Alright, so we want to make sure that any trade open during this time period is closed out when the next time period starts. So let's see, let's do some experimenting. So Thomas, what time frames are your charts set to? Are you using minute charts, range charts, Renko charts? I don't need to know exactly, but are you using minute-based charts, tick-based charts, range charts? Okay. All right, start. All right, so let's I'll put this back on a range chart here, and All right, let me give this a name here. All right. Okay, so there's today's BloodHound template name. All right, just a sec here. Let me just name this logic template from before. Okay, so we'll create a new logic template here. All right, so this will be, I'm going to try and figure out how to exit session 1 here. All right, so I'm going to start with the time session solver, like so. And let's see. All right, so I'm going to see if I'm going to try and build a session template here that'll exit me at 3 a.m. Okay, let's see if that does it. And let's see, Eastern time, actually, I'm going to change this to Mountain time so we don't have to do a time conversion on my chart. And where is it? There it is. Okay, let's see what we get here. There we go. Okay, so there we go. Those would be some exits. So you've kind of got a decision, Thomas. You can either exit the trades 1 minute before the next session closes. So let's see here. Let's see. You know, you could exit before. Let's see. Or you could exit afterwards. And let's see. Right, so we could exit the trade like, you know, a minute before or a minute afterwards. And let's see, actually let's finish. Let me do some further testing here. Let's make these 20 range charts here. Let's see, yeah, so if you're using a larger range chart, you will have to use a wider time frame because, let's see, yeah, we didn't get a bar that closed inside of this 1 minute range here, right? So we set up a 1 minute time range, and we didn't get a bar that closed inside of that time range. So on this larger 20 range bar, there was no exit signal. So yeah, so you will have to set up a range, a time range, that will work with the size range charts that you're using. All right, and so that's one thing to note. All right, so that would be exiting before the session ends. And the other thing would be to exit after the session ends. So let's create another time solver here. So okay, and this one I'll set an example of exiting afterwards. Now, so I'm showing you exiting after session 1 to make a point. So there is a point to this. So I'll get to it in just a moment here. Let's see. Alright, so let's get this set up here. So let's see, we'll see if a 5-minute time span is long enough for these 20 range charts. And let's see here. And wow, this 20-minute range, or this 20 range bar took 20 minutes to build. It's pretty long. Well, let me just modify this so that it works, and I can explain to you what the effect is of exiting afterwards. Let's see. Okay, there we go. So, right, I've got an exit signal exiting after 3 a.m. Now, what would happen is if you had a entry signal right on the first bar of session 2, so let's say right session 2 starts at 3 a.m. and you get an entry signal on this first bar of session 2, what would happen is that this exit signal would block, or it would prevent the entry signal. Okay, so when using Raven, if you get an entry signal and an exit signal on the same bar, Raven will ignore the entry signal, right? So if your exit signal fires off, right, it means that you're wanting to exit the trade. So therefore, Raven's not going to enter, or Raven's not going to execute a new trade when an exit signal is fired on the same bar. So that's part of that. So that could be maybe that could be an issue with how your system runs there. Because who knows if you get entry signals on the first couple of bars of session 2, these exit signals could be blocking those, right? So that's part of the problem That's one thing, to be aware of if you're, building exit signals after, after session 1. So, let's see, the other way to do this is to build 2 separate BloodHound logic templates. So you build one BloodHound file for session 1 and build a separate BloodHound file for session 2. That way they're not interfering with each other, and you'll have to run 2 instances of Raven on the chart as well. So let's see, let me kind of give an example here. So I'll just build one BloodHound template called session 1 and another one called session 2. Right, so you could break your logic up into 2 BloodHound files. And just a sec here, I need to save back to the workshop file name. So before I do this, let me point this out here, guys. I mean, some people don't realize how software save, capabilities work, right? And so what I'm going to explain is universal across all software. So what I just did, right, is I had a different, right? I had the Friday workshop, with the date file name up here, right? I had that up here, and then I just hit the change button, and I did a save as, right, to make session 1 and session 2. So when I clicked the save as, and I saved, and I created these new files using the save as, what happened is the original file name does not get saved, right? So just keep that in mind, right? This is universal for all software. When you hit the save as button, that doesn't save back to the original file name. So this original file here doesn't have any of the work that I just did in it, because I never saved it before I did a save as. Alright, so just be aware of that, guys. So I've had a couple of customers get fouled up because not realizing how all software save buttons work. So so if you're working on one file and you want to do a save as to just make a temporary test file, make sure you save your file first. Make sure you save under the original file name first before you hit the save as button. So, alright, so as I'm working in the original file name here, you want to go in here and just do a quick save before you go in here and start saving under a different name. So just to be aware. Okay, so I've got, alright, so I've got these 2 sessions here as an example. So now let's put Raven on here, right? So I can put 2 instances of Raven on the chart. And let's get this loaded up. Oops. There we go. Get those selected correctly. All right, so I got one BloodHound file for for session 1, so our 6 p.m. to 3 a.m. And then just obviously set your logic, your entry logic, and set your exit logic for that time. And grab the other Raven, and then I'm sure you guys have probably already guessed, I'm going to load up session 2 for the other one. should do. So in session 2, I guess I should rename this. There we go. So I'm just gonna let's see. Okay, so I'm just making a quick session template to exit session 2. Let's see, actually there's a 1-hour gap between session 2 and session 1. So I guess I would so I'll set this exit to exit after session 2. Yes. Okay, there we go. So I've got a BloodHound file running the logic for session 2. There we go. Let's select the exit logic there. There we go. And let me just double check session 1. All right, so the way I've set this up, just doesn't mean one's right and the other one's wrong, but I've set my exit for session 1. I set that to exit before 3 a.m. And then session 2, I set up to exit after session 2. So there you go. Let's see. All right, and let's enable both of these ravens. And all right, so there we go. So we got 2 ravens on the chart, and if we stretch this out here, there we go. All right. So we can see the raven buttons on the chart here, right? So we can see which one's running session 2 versus session 1. And let's see. Let me just take BloodHound off the chart to eliminate any confusion. And okay, there we go. So right, so the raven, the bloodhounds that we have for raven on here, right? We can see I have the exit logic selected, so we can see them on the chart here. So we can see right, Raven that's running session 2, right, it's going to be exiting the position here after 5 p.m. And then we have Raven that's running session 1, right, is going to be exiting, right, 1 bar before 3 a.m. So there we go. So that's another choice there, Thomas. So, you know, what's going to give you the most flexibility is this setup here, running 2 Ravens and breaking your logic into two BloodHound files here. Yeah, okay, so Thomas doesn't want to exit session 1 afterwards. So he doesn't want to use this one. All right, so Thomas wants to use this one, yeah. So, you know, obviously, Thomas, the issue you're running into is, you know, since you're not using time-based bars, you know, right, that's kind of creates an issue there. You never know when range bars are going to close, but of course, you know, time, you know, time is linear where range bars are not linear. So, you know, so when you're mixing and matching, you do create an issue for yourself. You know, so you just have to best decide, you know, how you want to handle that. So, yeah, you know, it just comes down to making that choice when you're mixing and matching non-time-based bars, you know, with time-based logic. So obviously, you know, your exit logic is time-based, but your bars are non-time-based. So it just, you know, creates those decisions that you have to make. So, okay, so Thomas is asking, let's see, so how do you combine other exit conditions, or yeah, other exit logic, you know, based on, I guess, indicator criteria. Yeah, okay. So essentially, Thomas has actual exit logic, you know, based on indicators and such. So let's see. Let's create something simple here. All right. So let me just create a simple crossover solver here. All right, so this is our time-based exit, and this crossover is just going to represent, you know, exit logic or exit conditions, you know, based on your indicators doing something. And let's see, I'll just use these moving averages here that I already have on the chart. EMA 50, okay. So what I've got on the chart is an SMA 10 and a EMA 55. All right, so, you know, so just as an example, if my, you know, if my moving averages cross each other, you know, that's going to be an indication to exit the trade, right? So, all right, this is my indicator-based exit logic, and this is just the time-based to make sure I get out when the session ends. So all you have to do is connect the two together with an OR node. And now I've got both. There we go. So now you can see here for session 2, I've got both. So right, this is my time-based exit that gets me out when the session ends, and everything else here is just the standard exit logic. So you know, if your exit logic fires off, you know, when you're out side of your session, that's not going to matter, right? Because there's obviously session. Yeah. Hold on a sec. Let me get a drink of water here. All right, so this is when session 2 ends. That's actually right about there. So this is when session 2 is not trading. Actually, this basically represents session 1. So session 2 is not trading during this time. So these exit signals here, all right, so these exit signals that are outside of session 2, they're not going to do anything because session 2 doesn't have any trades on, right? And so it's okay because you've broken your BloodHound, or you've broken your trade logic into 2 separate BloodHound files. So these exit signals will not interfere with your session 1 template, right, which is running in a separate Raven. So you won't have to worry about these exits here. So let's see. Anything else to explain? Yeah. Right. So basically, the answer to your question, Thomas, is you just use an OR node there. All right, let me take a look at the question board here. Let's see if there's some other comments here. So yeah, that's correct, Thomas, just an OR node. So let me just kind of mention, the OR node is just a pass through. That's all it does. The OR node allows everything connected into it to pass right through. So the OR node is a way of taking, multiple solvers or conditions, a way of taking, multiple nodes, and all it does is basically it combines them into one output. So just think of this as a joiner. It takes all the signals coming into the OR node and joins them all together into one single output like that. So there's yeah. So that's all the OR node is. And there's really no fancy logic to an OR node. So now which as compared to like an AND node, right? So an AND node only allows signals to pass through the AND node when all incoming signals all agree with each other, right? So everything connected to an AND node all have to have a long signal on the same bar to get a long output, to get a long signal at the output. Let's see, Joe is suggesting Thomas could add a time-based time frame. No, Joe, actually that would not work. Let's see, let's play around with this here. This kind of goes back to the original question this morning. What is the default time frame? If you do create like a minute based time frame and put your exit solvers on that, okay, actually here, let's see. Yeah, it's going to be better if I demonstrate this in BloodHound, not through Raven. So all right, yeah, I think we're done with Raven for now. So I'm going to take these off the chart. And let's put BloodHound back on the chart. Alright, let's get things loaded back up again. And okay, yeah, so my chart is still on a 20 range chart here. Okay, so let's do some experimenting. So let's add a 1 minute time frame. And let's see. Okay, so I'm going to take this time solver and move it onto the 1 minute chart. Alright, so we've got a 1 minute chart and we've got our time solver on here. Right, so this is exiting session 1 before. We're exiting before session 1. And let's see, once again, let's take a look at this again here. And okay, so we have a 10-minute window. Actually, just for the sake of this demonstration, oops, all right, I'm going to set this back to like a 2-minute window here. All right, so we've got a 2-minute window for this exit signal. Okay, so we're on the 1 minute chart and we created a 2-minute exit window. And let's go back to this exit session logic template. Okay, so so here we go. Here's our existing node on the 1 minute time frame. So let's put this on here. So there we go. So we can see this time solvers on the 1 minute chart. Let's plug that in there. And oh, we need to refresh the chart because I added that 1 minute time frame. And let's find 3 a.m. Yeah, so basically that's the bar just before 3 a.m. And here's a neat little trick with NinjaTrader. So when you draw objects on the chart, you can actually set it to a time and date. Right, so I put this at 3 a.m. exactly, and there we go, click apply. And you really sometimes have to stretch this out in order to see this. So you can see where the wick is. So let me get a little arrow here. So you see where the wick is right there? So that wick represents when the bar closes. So when I put my cursor over the bar, we can see it closed at 2:57 and 50 seconds. Right? So it closed 10 seconds before our two window time frame. Right? So the line here is at exactly 3 a.m. but we can see where the wick of the bar is. It happened before our 3 a.m. time frame. And actually what I should do is I should put 2 lines on there. There we go. So these 2 lines represent our 2-minute window for that exit solver. Right? So just to recap, if you guys remember, this session template here, I made a 2-minute window. And so we can see, so these two lines represent that 2-minute window in between. And we can see the bar, the wick of that bar, occurred just before the lines showed up. So we know that this bar is outside. This bar is outside of that 2-minute time span here, and so therefore there's no exit signal. So unfortunately, Joe, it's a good thought, but putting your solvers on a 1-minute on a time-based chart doesn't actually work. Because NinjaTrader goes by whatever the time of the bar is. So NinjaTrader goes by the closing time of the bar. That's when NinjaTrader looks at everything. So this bar closed at 2:57 and 50 seconds, and so that's when NinjaTrader evaluates everything. And so when we get into this 2-minute time span, the bar doesn't close. No bar closes inside of this 2-minute time span. So therefore, NinjaTrader is not evaluating anything, right? The next time NinjaTrader evaluates your indicators, which includes BloodHound, all right? The next time NinjaTrader evaluates something is when we get over to the next bar, which is at 3:20, right? So 20 minutes later, NinjaTrader evaluates again, and once again, this bar is outside of our 2-minute window. So that just didn't work out, unfortunately. So the key is to really make a time span, that's wide enough, that your last bar is inside of this time span here. That's how you get NinjaTrader to recognize your time solver lining up with the bar, with the bar's time. Let's see. Now, I guess just to further demonstrate here something that would work. Right. So if I edit this, we'll make a 5-minute window here, right? So we've got a 5-minute time span window here. Save that, go like that, and bingo. Now we can see there's an exit signal now. So let's correct this line here. Let's put this line so it matches up with that 5-minute time window. There we go. So there's our 5-minute time window, and we can see the bar wick is inside of that time window there. So, all right. Looks like Thomas has a follow-up. Thomas is just making a statement here. When you're working with non-time-based bars, the point that Thomas is bringing up is that you don't know, how long a bar is going to take to form, and so therefore you really don't know how long of a time span, that you need. And that's correct. That is kind of one of the issues that you run into when working with non-time-based bars. Yeah, it's just something that you just have to deal with. So, that's just one of the, I guess, inherent facts of working with charts. The x-axis on a chart is always a time scale, and then there's really no way to get away from that, right? And so you're mixing non-linear bars, with time, which is linear. So therefore, it does create, some hurdles that you have to just some hurdles that you just have to deal with. somehow. Find a way to deal with it somehow. Mike is asking, can I cover the if-then, relational, and truth table nodes? Yeah, you bet. All right. Let me get things set up here. Okay. Right, I'm just trying to think of a setup here to give a good demonstration. All right, just a moment while I set this up here. It's going to take me a little bit. So the first thing I'm setting up here are some signals to control the if-then node. So, and I'm just trying to set up something simple and easy to understand. There we go. All right, so I'm just going to identify right, these red and green areas on the chart. So we have a visual reference for later. Okay, so what I've got on the chart so far, so these are the signals that are going into the if-then node. All right, so here's my solver. So I just created, just some dummy signals to control the if-then node. All right, so the first thing you'll notice, right, the if-then has 3 connection points. So the if node is what controls the switch inside the if-then node. All right, so that controls the switch, and inside this if-then is a switch. And I'm going to bring up a drawing here to help illustrate the if-then node. Let's see, here we go. Just scroll down a little bit here on the side. All right, so I'm on our website here, and I've got a documentation page up, reference page. So I've got the menu here, the documentation menu. So I'm going to scroll down here to logic nodes. There we go. Here's the if-then node under the logic nodes. And looks like my browser locked up. Yep. Hey, Internet Explorer crashed. All right. All right. Let's try this again. There we go. Okay. So here's the reference guide for the if-then node. on here, right, I've got some graphics on here to illustrate how the switch works inside the if-then node. So let's just kind of take a look at the basic one here. So inside the if-then, there's actually two switches, right? There's a long switch and a short switch. Right? There's two switches in here because, you know, as you guys know, BloodHound gives you long signals and short signals, right? So kind of going back to the fundamentals of how BloodHound works, right? Where if we look at BloodHound, you'll notice BloodHound has two separate plots, right? There's a long confidence plot, which is, right, the green or the buy signals, and then there's a short confidence plot, which is the red, right, the red or the sell signals, right? So we have two plots. So everything in BloodHound is evaluating kind of, well, not evaluating twice, but BloodHound is evaluating the long signals completely separate from the short signals, right? So there's two separate evaluations going on, right? And they don't interfere with each other, right? So BloodHound's calculating the long signals separately from calculating the short signals. So that's why the if-then node has two switches in it, right? So there's one switch that works for the short confidence, and then there's another switch that works for the long confidence. So let's take an example here. All right, so if we look at this graphic, we can see, so say if a long signal comes in, right? Only a long signal comes into the if node. Then the way the switches look is the long switch here in green is connected to the then node. So what happens is long signals connected to the then pass through to the output, right? And for the short side, since there's no short signal, the switch for the short side, for the short confidence, connects the else to the output, right? So short signals on the else will pass through to the output, whereas long signals from the then will pass through to the output. All right, so these switches can be in any combination depending on if a signal comes into the if node or not. So let's just take a look at another combination here. All right, so this is the opposite kind of situation. So let's say a short signal comes into the if. Well, then short signals connected to then pass through to the output, whereas long signals are going to be coming from the else passing through to the output. And then, of course, the last combination is, well, if you get a long and a short signal coming into the if, well, then both switches are going to be passing through the long and short from then to the output. All right, so based on that's kind of, let me set up some examples here. Yeah, I'm going to put some more indicators on the chart here to help illustrate some examples better. Alright, so I've got a stochastics and a MACD on here. And I'm going to brighten up the 0 line on the MACD. Okay, so what I'm going to do is I'm going to make some solvers. I'm going to make some solvers that we can connect into the then and connect into the else, right? So, just be mindful. You don't have to have something connected into the then or the else. I should say you don't have to have something connected into both. So you could use the if then to just connect something into the then or the else, one or the other. You don't have to be connected to both of these to use this. Well, let's see. Okay, so let me create some solvers here that I can connect up to this if node. Alright, let me just name these guys here. Okay. So let's see, I'm going to use this threshold solver and just generate some basic signals from the stochastics. Alright, so I'm just going to throw this together real quick. So one thing to note when you're using those stochastics, if you're using an overbought and oversold levels for the stochastics, with the threshold solver, you always want C to be some value in the middle, in between your overbought and oversold areas. So, so I was just as a reminder that you want, when using the threshold solver, you want the threshold levels to be in descending order, right? So they're in descending order right now. So that's why there's a 50 there. If I left it at 0, then they're no longer in descending order because 0 is less than 20. So that's not descending order anymore. So there we go. All right. So here we go. Some very simple signals for this stochastics. And I'm just going to make the lines a little brighter. There we go. So we can easily see when the stochastics is overbought or oversold. And so that's one solver. I'll connect that into the then. And I'm going to make one more threshold solver. Connect it into the else here. And so this will just be some more example signals. So I'll just check to see if the MACD is above or below 0. Real simple and basic. Alright, so if the MACD is above the 0 line, we're going to get a long signal. And if it's below the 0 line, we're going to get a short signal. So there we go. Real simple to visualize on the chart here, right? MACD above or below that 0 line. Okay, so now let's take a look at our if-then. So let's start off as a, just as a reminder, start off by looking at what's going into the if. So remember, I drew the rectangles here, the colored rectangles, so that tells us whether it's a long signal or a short signal going into the if, right? So these long and short signals is what's controlling the if-then switches, right? So these long and short signals are controlling this switch that's inside the node. Okay, so now let's take a look at the result here. Let's see, let's start over here. Okay, so remember this area here. Let me shrink things down a little bit. Hold on, let me make this a little brighter here. There we go. Alright, so we have a long signal coming into the if node. So what's happening is the long signals from the stochastic solver is what's passing through to the output. Right, so we can see right here the stochastic is oversold, and we can see those long signals are what's passing through to the output there. Right, so remember we have the solver here that's looking at our stochastic, and so that's connected to the then. So on the long side, then is passing through to the output, right? So these long outputs are coming from the stochastics, and let's see, yeah, okay, and there we go. Now, this short output from BloodHound, that is coming from the MACD. So remember, right here, draw a little line on here. Let me get some separation lines here. There we go. Okay, so remember on the left side of this line, right, we have a long signal coming in. So long signals from the stochastic are going to pass through the if-then node. And then short signals from the MACD are going to pass through as well. Right? So remember the MACD is connected to the else. So this area here where a long signal is coming into the if, let's shrink this up. Let's see, what are we looking at? We're looking at this scenario here. So if we look at how the switches are, all right, we have a long signal coming in. So long signals from then is what gets piped out to the output, and short signals from else is what gets piped out to the output. Right? So that's why the short signals from the MACD get piped out here, right? And long signals from the stochastic is what gets piped out to the output. Right? So the long signals from our stochastic solver go through to the output, and short signals from the MACD get piped out through the output here. Alright, let's take a look at the next block here. So let's take a look at this block. Okay, so this area, right, we've got short signals, remember, so this means that we've got short signals coming into the if connector, to the if node. So what's going to happen is short signals right, so the short signals from the stochastic pass through, right, and it just so happens that the stochastic is oversold right here for a couple of bars. So these three short signals from BloodHound are coming from the stochastic being oversold. Right? They're not coming from the MACD anymore. It's just a coincidence that the MACD is below 0 and the stochastic is oversold, right? It's just a coincidence. But these short signals are coming from the MACD solver here. And just to illustrate a point, if I disconnect, so let me disconnect the stochastic solver, and now we can see, right, the short output disappeared here. That's because there's nothing connected to the then. So the short signals, right, so there's no short signals getting through to the then. However, over here, so remember, let me put some more lines on here. Okay, so we can see, so for just one bar, that MACD popped above the 0 line for one bar. So this long signal is coming from the MACD. Alright, so let's take a look at how the switch is now. There we go. So for this area on the chart here, this is how the if-then node is, and this is how the switches are set up, right? So we have a short signal coming into the if connector, you know, for these bars right here. So long signals from the else node are passing through to the output. So that's why this long signal here is coming from the MACD. Remember, because the MACD is what's connected to the else. So, and short signals from then are getting piped through to the output. But remember, we disconnected then, so there's nothing going to get through. But if I connect that back up, like so, now the stochastic short signals are passing through the if-then node. So, let's see. I guess you know, I think that pretty much demonstrates it. I can continue on if anybody would like me to keep showing some examples. I can just keep moving down the chart and show some further examples. So please don't be shy if you need some more examples here. Just to speak up. So I won't mention your name. I don't want any embarrassed customers in here. Let's see. So yeah, it looks like I'll continue on here. So all right, let's move on to the next section of the chart here. Let's move on to this little area here. Okay. All right, so moving on to this area of the chart. So we have long signals coming in to the if node. All right, so remember the long signals are coming from this solver here, right? So remember, this solver is just looking at, just the SMA 10 above or below the EMA, right? That's all this solver is doing. So if I connect that up, right, we've got long signals coming into the if node. So what does the switch look like? So the switches look like this. So the long switch is taking long signals from then and piping it through to the output. So in other words, it's taking long signals from the stochastics solver, right? But the stochastic solver doesn't have any longs because it's not overbought, right? It's in this neutral area, so that's why there's no long signals here, because our stochastic didn't give us any long signals here. Now the MACD is below the zero line, so it is generating some short signals. So these short signals here are coming from the MACD. And if we look at our switch over here, if we look at our graphics, right, short signals from the MACD are passing through the else to the output. So, let's see. Let me find another example. Let's see if I wonder if maybe I could find an area where both long and short are passing through the if-then node at the same time. Yeah, it looks like the MACD and the stochastics are too much in sync. Oh, here we go. Well, there's one bar. Wow. Yeah, let me go back to this. We got one bar here that demonstrates, let's see, yeah. All right, so we have a short signal coming in to the if-then node. just a moment. Okay. So this is the signals coming into the if-then node. Actually, there. So yes, all of these bars have a short signal coming into the if-then node. Right. So this solver is giving us a short signal into the if connector. There. So with a short signal coming into the if connector, let's see, this is how the switches are configured. All right. So we're going to be taking short signals from the stochastics, where we'll be taking long signals from the MACD. So let's take a look at this. So right here, our stochastic is just barely in the oversold. So our stochastic is generating a short signal. So that's why we get the short signal on this one bar here. Right? So the short signal here is coming from our stochastic being oversold, and the long signal is coming from the MACD. So the MACD we can see is above the zero line. So the MACD is giving us a long signal. And so this long signal is coming from the MACD. Right? So with only there's only a short signal coming into the if. So long signals from the MACD pass through the else to the output. So that's what we got here. So the MACD is connected to the else. And so if the MACD is giving us a long signal, it's going to pass through to the output. Right? So actually, those two bars there are coming from the MACD, because the MACD is above the zero line, and the signal, just a moment here, and the signal coming into the if is short. Right? So we got a short signal coming into the if node for these two bars, which means the long signal from the MACD passes through the else to the output. So and so those three short signals there are coming from the stochastic, because the stochastic is oversold. Right? So if we look at the graphics again, short signals from the stochastic pass through the then to the output. So all right, well, I think I'll stop right there for the if-then node. You know, the real, you know, if you are wanting to use the if-then node, if you think you need it, you know, just always refer to the page here. You know, refer to these graphics images here to help give you a visual reference that you can, you know, that you can use. So, all right. So when you go to get to this page, what you want to do is just, you know, go to the Learn BloodHound on a menu here, and then just scroll down the side menu. Scroll down this side menu, and you'll find the if-then is underneath the logic nodes. All right, and there it is. So, and if you look at BloodHound, you'll see from the logic node menu, right, the if-then is underneath the logic node menu there. So, just the exact same as this menu shows here. So, all right, so that should cover it for the if-then. let's see. So Mike is asking, do you have to use two different indicators? No, absolutely. I'm using, for my demonstration, I'm using two different indicators because it just kind of keeps it simple to demonstrate. You can plug into the if-then whatever you want, whatever you need, right? So just bottom line is, think of the if-then as a switch, right? So it's going to either allow signals through or it's not going to allow signals through. And so the if-then, and when you're thinking of it as a switch, just remember that always one of these is going to be connected to the output, right? So either then will be connected to the output or else. One or the other will always be connected to the output. So the switch is always connecting to then or else. It's connecting to one or the other all the time. Right? So to bring up the graphics again, right? This switch always has to be connected to then or else. It has to be connected to one or the other. What you do, so kind of to summarize the use of this node is, right, you've got a set of logic that controls the switch, and then you have other logic here that gets decided what goes through to the output. So if if you have an elaborate system, and actually this is a very common practical use. I'll build a common, the way most customers are commonly using the if-then. Let me do that here. Let me get back. Where did the chart go here? I lost my chart. Here it is. All right. All right, so I'm just thinking of something here. Yeah, okay. Here we go. Here's probably a more practical example. Let me start over. Okay, I'm going to start fresh here. And so I'm going to build a simple signal that's going to control the if-then. And I'm going to answer two questions here in one. Yes. Okay. So John's got a question here that's off topic, but I'm going to actually answer it here for you, John. So John's asking, which node would you use to see if price closes above or below a moving average? So that's what I'm going to do right now. So I'm going to build a solver that's going to check to see if price is above or below a moving average. So we're going to use the comparison solver, John, to do that. So John, what you're doing is you're comparing price to a moving average. So we're going to use the comparison solver. And so we're going to set indicator A to price, and we're going to set indicator B to our moving average. And in this case, I'm going to use the EMA 55 that's on the chart already. All right, so this is the EMA 55, the red line on the chart. Okay, so here's the most common practical use of the way people are using the if then node. So someone will say, okay, I've got a set of logic that tells me if I'm in an uptrend or a downtrend. So I'm just going to use this very simple comparison here. So let me name this solver here first. All right. So I've got this very simple trend, logic here, right? So if price is below our EMA, then we're in a short trend. If price is above, then we're in an uptrend. So the way this if then is commonly used is someone says, well, I've got one set of logic that I want to run when I'm in an uptrend, and then I've got a different set of logic to run when I'm in a downtrend, right? So he's got these two different logics, one for uptrend and one for a downtrend, right? So I guess it'd be, a different set of logic, for your buy signals and a different set of logic for your sell signals. No. So what we'll do is we're going to take this and we're going to use the if-then node to decide, when to use, the long signal logic and when to use the short signal logic. So what you do is you take your solver, and remember, so this one solver could be a whole bunch of solvers that create, a logic. So I'm just using one solver as a simple example, but this could be far more complex, that I'm using to control the if-then node. So what I'm going to do is I'm going to use the long-short modifier. And there we go. Okay, so now when we look at the chart, right, we can see when we're in the in the uptrend, right, when price is above our EMA, when we're in an uptrend, we have long and short signals. We have both. Right, we have both long and short. So what that means is whatever is connected to then passes through to the output. Right, so we have a long and short signal coming into the if, and if we go back to our graphic here, so remember we have this one graphic image that has a long and a short signal coming into the if, and so both switches are connected to then. So everything connected to the then gets passed through to the output, and whatever is connected to the else is completely ignored, right? Completely ignored. So let's let me drop a couple of my let's see. I'll go back to my simple stochastic and MACD solvers here. So what's going to happen is when we're in the uptrend, so when we're in an uptrend here, right? When price is above our EMA. The stochastic overbought and oversold is going to pass through, is what we're going to see. That's connected up there. There we go. And you know what? Everything is so synchronized right now. Okay, yeah. So here's an example. So right here, we have a couple of bars that are above our moving average. So we're in that in a long trend, and we can see we got, and the stochastic went oversold, and so we actually did manage to get a couple of sell signals from the stochastic, for a couple of bars. But typically, we're always getting buy signals from the stochastics. Yeah, it's just because all of these indicators are all they're all closely synchronized, right? So whenever price seems to be above our moving average, our stochastic always seems to be in a buy situation here. Let's see if I can find any other short signals. Yeah, here we go. Yeah. So once again, so what we're seeing is, right, so price is above our EMA, so we're in a buy trend, or in a long trend, and our long signals are coming from the stochastic because it's overbought. And these short signals, once again, price is above our EMA, so we're in a long trend again, but our stochastic went oversold temporarily. So we got short signals from the stochastic. Right? So bottom line is, when price is above our EMA, we're going to get signals from the stochastic. And when price is below, let's see, here we go. Yeah, so in this area we can see price is below our EMA for quite a bit, and we're going to get signals from the MACD here. So let me connect the MACD into the ELTs. Okay, there we go. So we can see price is below our EMA, and so these signals are coming from the MACD. So we can see over here we got a couple of bars where the MACD is above 0, and so we got some long, and then the MACD goes below 0, and so we got some shorts. So that's kind of the common use is for this if-then is somebody has a set of logic that kind of determines whether they're in a in a long trending state or a short trending state, and then they have two separate sets of signal logic that the if-then will control which actually gets through to the output. So, and the key is this long-short modifier, right? And I set it to mirror the long. In this case, I set it to mirror the long. Really, how your logic, how your trend state logic is set up, really kind of depends on how you want to set the long-short modifier up. But for this example, I use the mirror long, and so the key is that when you're in a long state, or if you're in a short state, well, I guess I'll just keep it simple. When you're in a long state, right, you want both long and short outputs at the same time. And when you're in the other state, when you're in a short state, you want no output. And so that controls the if-then, so that both switches are either to the then or to the else. All right, so once again, if we look at the graphic image, when you get long and short signals coming in, that means both switches are going to the then. And if there was no signals, then of course both switches would be connected to else. So, using this long-short modifier so that you get long and short signals together is what keeps both switches to one or the other. Keeps both of the switches together. So, if this seems a little fuzzy in your head, don't worry about it. Don't expect to get it the first time around, but when you just kind of mull this over in the back of your mind a little bit, then all of a sudden it'll just crystallize, and it'll seem a lot simpler. This really is a lot simpler than it looks like once you kind of get the concept. All right. Let's see. All right. So John, hopefully you got the answer to your question here about what solver to use for price above or below moving average. So I just used the comparison solver here, right? So I set A to price, and you set B to whatever moving average you want. And so there you go. So whenever price is above your moving average, you're going to get a long output. And when price is below your moving average, you're going to get a short output. Mike also asked about the relational node. Okay, let's see. Let me pull up the website here. All right, so I'm going to pull up the page for the relational node. Here we go, right here. So with the relational node, it does some simple comparisons between input A and input B, right? And there's a huge list of different comparisons, right? So is A greater than B? Is A less than B? Does A equal B? Is A not equal to B? Right? Is A less than or equal? Here actually, sorry. Let me put the solver up. It'll probably be easier to read that text. All right, we got a relational node here. So here's the list of all the different types of comparisons that this can do. All right, so the most common ones is we can check to see if A is greater than B or less than B and equal to B. All these different things. This one, A is not equal, so the exclamation means not equal to B. And of course, the help guide page, explains what all these mean. So like right here is A not equal to B, or right, exclamation equals B. So there's a explanation of what all of these modes are. And then there's even an A minus B, or a B minus A, and the absolute of A minus B. So the relational node, its practical use is when you're using fuzzy logic, right? This guy really, yeah, its most common use is for fuzzy logic. Trying to think of some examples here. Okay. Let's bring my chart back up. Let me take a look. See what I can use. Okay, I think I can come up with an example here. Alright, I'm going to have to build some fuzzy logic type solvers here to kind of illustrate. Alright, so let me put these solvers together first. Okay. So let me illustrate what these solvers are going to look, what they actually look like here. Okay. So you can see I've got, so this solver here is looking at the stochastic. And let me put one more line on here. So I'm going to put this on the 50 line. All right. So this threshold solver, right? I designed it in a fuzzy logic fashion here. So if you look at my thresholds, they're 100, and then 50, and then down to 0. So we can see when the stochastic crosses above 50, right, the output of that solver goes positive, right? And you can see it basically the output of that solver rises and falls as the stochastic rises and falls. So you know, the closer the stochastic gets to 100, right, the greater the output is going to be. And the lower the stochastic, the lower the output's going to be. Yeah, here we go. So our stochastic got down to basically 7, and the BloodHound's output, right, got down pretty low as well. So, all right, so that's one fuzzy logic solver. And here's another one. This one looks at the MACD. And so the MACD, I set this threshold solver up to look for when the MACD gets to a value of 4 or -4. So let's take a look here. Yeah, so we can see, so you see the dotted lines, so the dotted lines are on 4 and -4. So the MACD got below -4, and so the output maxed out, right? And we can see here when the MACD moves back to the 0 line, right, we can see the output diminishes, and then it goes positive as the MACD goes above the 0 line. Right, so I've got a couple of fuzzy logic solvers here. And so these fuzzy logic solvers here will help kind of demonstrate how the relational node is going to work. So let's see, let's do a simple one. Let's check to see when A is greater than B. So A, remember, so A, we have the stochastic here. Let me zoom in again. Let's zoom in. So the stochastic solver is connected to A, and the MACD is connected to B. So what we're doing is we're checking to see if the stochastic solver is greater than the MACD solver. And let's see what we get here. Yeah. Let me, there we go, point this out. So the stochastic is above the 50 line, so it does have a positive or a long output. Whereas the MACD, it's below the 0 line, so the MACD has no positive output. So basically what the relational node is telling us is that the stochastic output is greater than the MACD output. So and that's for the long side. So once again, keep in mind, remember how I explained earlier that BloodHound is always evaluating the long side separate from the short side. So really what the relational node is looking at on this bar is the relational node is saying, okay, the stochastic is above 50, so it has a long output, but the MACD is below the 0 line, so there's no long output. So therefore, A is greater than B. And since our stochastic, which is A, is greater than B, we're getting a long output here. Okay, so now, if we go over here, so now the stochastic is below 50, so the stochastic is negative. Right, let's just take a quick look here. Right, so right here's the output for the stochastic, and it is negative. And let's see, it's at approximately 0.42. Right, so our stochastic output is approximately 0.42. And so let's look at the MACD. So our MACD is also below 0, so it's negative. But if we look at the MACD value, it's about at 0.3. Yeah, it's somewhere around 0.3. So the MACD is less than the stochastic. So in other words, the stochastic has a greater output than the MACD for these 3 bars. So therefore we get a short output. Now if we look over here, actually the MACD has a greater output. So in other words, B, right, input B actually has the greater output. So is A greater than B? No, it's not. So therefore there's no output. So, right, so this area here that I marked, A is not greater than B, so there's no output. Right? So there's only an output when this statement is true. So when A is greater than B, when that's true, we're getting an output. Right? So we can see on our outputs it says output if true. So when A is greater than B, when that statement is true, that's when we're getting these outputs here. Right? So once again, if we take a look at just this single bar here, if we look, the MACD kind of moved way up, and the stochastic moved up a little bit, but still, the output for A was greater than the output for B on this one bar. So that was a true statement, so we got a short output as a true statement. So that's right. So that is how the relational node works. So right. So you have all of these conditions that you can check to see if they're true or false. Right. So all these conditions are all true or false statements. Right. So yeah. So that basically, in a nutshell, that's kind of how the relational node works. Also, let's see, let's bring up the web page here. So really I didn't explain anything different than what's already in this video. So, and I'm pretty sure that this video probably goes into a lot more length and detail than what I went through. Okay, so Frank is asking, when using a relational node, can the value of one integer or a data series value be added or subtracted from each other? No, actually no. Yeah, you're probably looking at the A minus B or B minus A. So right, there's only subtraction here, and so let's put it on A minus B. So, like for example, let's just we'll take a look at this right here. Yeah, so this relational node kind of is doing a subtraction when using the A minus B. So we can see that the stochastic is above 50. So the stochastic has a long output. The MACD, it is below 0, so there is no long output. So the long output is 0. So what we're doing is we're taking, so A is this long output minus 0, minus the MACD, which is 0. And so this is what we're left with. So this is the output that we're left with. So basically it's, this output for A minus the output here for B, and this is what we're left with. So let's see here. So yeah, let's go back to here. So we can see that the stochastic is negative, right? It's below 50, so it has a short output. The MACD also, it's below 0, so it has a short output. And so BloodHound's output is the difference between the two, right? So it's taking the output from A, so this is the output from A, and it's subtracting the output from B, and this is what's left. This is the difference. So, yeah, there's no addition on here, and so kind of the reason why there's no addition is, remember, keep in mind that BloodHound's output only ranges from 0 to 100%. So in other words, from 0 to 1, right? So, and that's why, if you put an addition in there, basically, pretty much everything would just max out at 1, in the relational node. So it doesn't really make much sense. However, there's always an exception to. Seems like there's always an exception to every rule. So if I grab a long short modifier here, we can see that there actually is an addition function here. However, this addition function might be working differently than what you're expecting. So this addition actually adds, it takes the long side and it adds it to the short side. Right. So this addition is not adding long to long, it's actually adding short to long. So there is a subtle difference here. There is not a solver that will add the long to the long. But what you could do, if you're looking to add a long output to a long output, then what you do, this gets a little tricky, but let's see. Just trying to get this straight in my head. Here. Yeah, all right. So let's use these guys as an example. And this gets a little hairy. So if you're wanting to add like a long output to a long output, I'm going to have to do a couple of things here. All right, let me get this set up. Okay, so what I've got is, let's see here. Okay, I've got this solver set up so that it's only allowing long signals through. All right, so you can see I took the short side, I turned the short side off. And, oh, hold on, I'm going to turn off all the inverters. There we go. So only the long side is passing through. The long side is set to true. The short side is set to false. So basically, this solver here, if we look at it, it's only allowing the long output. It's only allowing the long output from the stochastics, right? And so, let's say we wanted to add, excuse me, let's say we wanted to add the long output from the MACD to the stochastic. So what we have to do is we have to use some function nodes and kind of do some manipulation here. So let's see, let me take the MACD. I'm going to plug it into this long short modifier, and let's see, just a sec here. I did have that set up correctly the first time. Yeah, there we go. Okay, so the MACD, right, if we take a look at the MACD, right in this area here, right in this area, we can see the MACD is above the 0 line, so it's giving us, right, a long output. But what we have to do is we have to reverse this, or swap this into a short output. So that's what this solver is going to do, right? It's in swap mode, and I turn the long side off, so only the short side gets through. So now, hold on a sec, let me adjust the scaling here. There we go. So now instead of the MACD giving us a long output, right, we reversed it into a short output here. And so now, as I was saying earlier, the long short modifier, right, to use the addition function, if you want to add the long side of one solver to the long output of another solver, right, you have to take one of your solvers and flip it so that it's swapped or reversed to a short signal, and then take the other solver, right, and isolate its long only output. And then what we do, let's see, there we go. Let me just name this solver, name this function node here. So we're going to put both of those in the OR node. So remember, the OR node just joins everything together. So if we look at the output of the OR node, so we now have a long output coming from the stochastic and a short output coming from the MACD. And so now the long short modifier here, using its addition mode, will now add the long and short side together. And let's take a look at this. Okay, there we go. So there's the outputs added together. Right? And then you may, since really you're doing all this fancy logic to add, the long output together, right? You probably only want the long output. So we'll just turn the short side off. Turn the short side off for this guy that's doing the addition, and we're left with just the long side being added, right? So you do have to do some manipulation here to do some addition, right? And so you'll have to do basically you'll have to create a group of this logic, one for the long side and another separate group for the short side, to add short outputs together. So right? So yeah, so you need a group like this for the long side, and you'll need a separate group to add the short side together. So there you go. And then, so if you have a separate group for the long side and a separate group for the short side, then once again you'll use another OR node to combine it back together. So that way you get just one output. So, okay, let's see if there's any other questions on here. We're getting pretty very technical today. All right, so Frank is trying to give me some more detail on what he's trying to do here. All right, yeah, so what Frank wants to do is Frank has a negative value that he wants to add. He wants to add to, I guess, a positive value. Yeah, so am I understanding that correctly, Frank? I guess you've got one indicator, or solver generating a positive value, and then you have a different indicator or solver generating a negative value. But so Frank, BloodHound doesn't actually operate in negatives. So BloodHound operates in confidence levels. So really, it's going to go back to let me pull BloodHound back up, right? So BloodHound operates in confidence values. Are you 0% confident that your condition's met, or are we 100% confident that the condition is met? So BloodHound doesn't actually BloodHound doesn't work in negative values, right? So the short confidence, it is a confidence from 0 to 100%, which is a positive value. Even though when you're looking, even though when we're looking at BloodHound, right, the short side, it shows up as a negative value, right? But the short side shows up as a negative value just for visual representation, right? I mean, what would happen if both the short and the long were both positive, right? They would stomp on top of each other. You couldn't see one or the other, right? One of them would get hidden underneath the other. So that both the long and the short can be seen at the same time. Let's see here. Let me just kind of make something up. Here we go. Okay, right. So here's a perfect example here. So, right, we're getting both a long and a short output at the same time, right? So if the short side was shown as a positive value, which really is what it is when it's evaluated, right? One of them would get hidden from the other, right? Either the long signal would get hidden, would get covered up by the short signals, or the short signals would get covered up by the long. So what BloodHound does is it takes the shorts, and just before it outputs it to the chart, it takes the shorts and converts it into a negative value. So that way we can see both above and below the zero line, right? But internally, really the short signals, the short side is a positive value, right? It's a confidence value ranging from 0% confident to 100% confident. That's right. It's only on the chart does the short side actually look as a negative value. So yeah, so BloodHound doesn't deal in negative values, right? Solvers don't work with negative values. Internally, they're all positive values. And it's this result node that takes the short output and converts it and switches it to a negative value. So yeah, so Frank, if you have an indicator that generates like a -1 value into a data series, the solver is only going to show you that -1 value. Internally, it's going to be a +1 value. It's going to, it'll be a +1 value, I guess, for the short side. So if you're wanting to take, like a positive value from your indicator and subtract it from a negative value from your indicator, I think the relational node will do that for you, right? So you could do A minus B, right, or B minus A, or you could get the absolute of A minus B. Or Frank, maybe maybe the where to go, the difference function here might do what you want to do as well. So let's see what happens here. Yeah, so here's the difference in action here. Excuse me. All right, trying to get things lined up. All right, so if we look at BloodHound's output here, right, so we can see the long side is rising, right, even though I switched this over to do subtraction, right, so it's doing a difference here. It's doing a difference. But still the output's rising. And that's because over here, right, the MACD is increasing on the positive side, but our stochastic doesn't have a positive output yet, right? It's negative. So basically what we're doing is we're taking the MACD minus 0, and so therefore the output's rising. Now once the stochastic starts to have a positive value, now, sorry about that, now we're taking a long value from the stochastic and subtracting it from a long value from the MACD, and so now the output starts to diminish because we're actually having a value to subtract from each other, right? So on this side of the line we have 0 subtracting from something, and so the output keeps rising. But over here we actually have a value, some positive value subtracting from some positive value, and so the output diminishes. So Frank, I think this logic here will work for you. At least it'll get you very close to what you want. You might have to manipulate things a little bit to work, with your indicators, because it all depends on how you've got your solver set up and things like that. But hold on a second. Let's see. Looks like Frank has wrote something else in here for me. Um, oh, okay, sorry, Mike. Frank, yeah, let me turn your... Um, oh, okay. So, well, so Frank, I guess, do you want me to still turn your mic on? I'm not sure if you want to hold your question till next time, or if you still want it, if you still want me to cover it today. Okay. All right. Yeah, Frank, just a moment. Let me find you on the list and I'll turn your mic on. Okay, there we go, Mike. I'm sorry, Frank, your mic is on.
Thank you. One of the reason I'm going through this is I didn't want to be setting entries and exit points based on events, but on scores.
Hmm.
In other words, I wanted to use, I know there's a scoring feature uh, in BloodHound where you can accumulate values and make a trade entry based on scores. And that seems to be okay from what I understand, at least by adding. However, the opposite side is when the score goes below a certain value or starts to decrease. The indicator that I'm writing, the intent was to use negative values to show a decreasing situation. And that would mean it would have to be, a negative value would have to be added to the score, and that was where it falls apart. And I understand what you're saying, that the whole thing only deals in positive values, which I didn't realize. I thought the adder would take a negative value and decrease something, but it doesn't. So I don't think we need to go any further. I need to write this up for you because to see how, because this whole using scoring to enter trades is a little bit I don't have a handle on it yet.
Yeah, okay. Um,
I don't know that there's anything that covers that. It's probably a little bit more intricate than just the stuff that's here.
yeah, well, I think, um, yeah, well, actually, like I said, actually, if I'm understanding you correctly, I think this difference will do what you want it to do because the
Yeah,
difference,
maybe I didn't know that was there.
yeah, the difference, once again, the difference is going to be taking the long side and subtracting the short side. So if your indicator is giving a negative value, I imagine that your solver is generating a short value when there's a negative value from the indicator. Does that sound like how you have your solver set up?
I no, no, I didn't, because I got hung up a little bit on uh, trying to use the adder.
Mm,
So I haven't gotten back to it after the last time we went through this a little bit, and that's and anyway, that was where I was having a problem. But you didn't even mention this differences thing, so I wasn't even aware of it.
yeah, okay. Um,
Yeah, what I'd like to do is, and I've been trying to do this and I haven't gotten around to it yet, is give you a brief description what I would like to accomplish um, using scoring instead of the way you normally do it, and see if you can go through something like that.
yeah, okay,
Because
yeah.
I haven't seen that in any place before.
All right, yeah, that sounds good. Let's see, just to kind of give you a starting point, um, let me, I'll take a threshold solver and let's see. So let's say you have an indicator that has some kind of scoring system that goes all the way up to a +4 and all the way down to a -4. Um,
Now I've done this already, so I'm okay with that.
yeah, yeah, so setting up a solver this way, what would happen is if your indicator gave a 1, gave a 1, then the output would be 0.25, right? A quarter. The output would be a quarter. If your indicator gave a 1. If your indicator gives a 2, then the output from the solver is going to be 0.5. So what you're going to be doing is you're going to be converting everything into a fraction when you're doing your math, right? Because BloodHound's output only goes to 1 or 100%. So you basically take the highest score value from your indicator, and everything else becomes a fraction of that highest score value. Right?
Okay.
So if your indicator has a highest score value of 6 or -6, then everything gets converted into a sixth, 1/6. So then all your math deals with 1/6 of, and so forth. So yeah, and and then so with your solvers, basically set up like this, then you can go back and start using the long short modifier, to do the math for you. Do the addition and the math for you. So.
Okay.
Yeah.
I'll have to play with that a little bit.
Okay. Yeah. Yeah. The exact solvers, the exact setup, it really all depends on the various math involved on your system. So there is no one way to do it. It's pretty much which function nodes you want to use, versus maybe using an additive node. It really it does depend exactly on your mathematical kind of system.
Right.
To say so. Yeah.
Yes, I mean, because everything that is being returned from the indicator is a value. I think the only thing that, from a node point of view, is the threshold solvers, to interpret them. But how to combine them into other things is where it's fallen apart a little bit for me.
Okay. Yeah, when you get into complex systems of evaluation like that, yeah, that's kind of where you have to start. You have to sit down and, I guess, create yourself a chart, or some kind of a roadmap, to map it all out, to get it clear in your head, and then from there you can start deciding, which solvers can accomplish, each little piece in your roadmap.
Right. Now, the thing that threw me is not being able to pass a negative value to the emitter.
Yeah. So, yeah, there you go. Well, yeah, 2 ways of doing it. Depending on. So. All right.
All right, but I don't want to drag it on for today. I'll write something up. Maybe we can go through in a little more detail.
Yeah. All right, Frank. Sounds good. Yeah.
Okay. Thank you.
All right. You're welcome. All right. Let's see. I don't see any other questions on here. Today got very technical and in-depth, so maybe we kind of blew a bunch of people's minds here. Maybe it's time to go take a little cat nap and grab some more coffee. Either that or just call it a week and start the weekend after this and just relax. So